guys. Today we're talking about 3.2 sine-cosine graphs. And most importantly, we're talking about amplitude and period. So what I want you to do is to go to my Edline page and click under assignments. There is a folder called Unit 3, and I posted these notes under Unit 3. And go ahead and print those out so you don't have to write everything down. So go ahead and press pause and do that, and I'll be waiting. Okay, starting off, we are talking about amplitude first. So the amplitude of a sinusoid is the distance from the sinusoidal axis to the high point or low point on the graph. So when we were doing spaghetti trig today, and I'm just going to use cosine as the example, we made, pretend we had green spaghetti, and it looked roughly like this, give or take. Okay? And it goes on forever and ever. So the cosine graph looks kind of like a roller coaster. Pretend that looks pretty. But the sinusoid, the amplitude, so would be the distance between the high point and the axis. So my axis would be the x-axis for our parent function. And this would be true, so for the parent, let me write this, parent function of sine and cosine the sinusoidal axis would be the x-axis. Okay, so it would be the distance from the high point to the middle, or you could do it to the x-axis down, either one. Okay, a cycle is the portion of the graph from one point on the graph to which the graph repeats itself. And we talked about this in class, both the sine and cosine for the parent function, so it would be 360 degrees or 2 pi, whichever one we were talking about, okay? So another way to look at the amplitude is our vertical stretch or compression. And now this brings us back to Unit 1. Let me finish writing compression. Okay, remember in Unit 1, this is like our A value, and it's whenever it'd be like A cosine, or it could be sine of x. It's on the outside of our function. Okay, so this is our vertical compression for our amplitude. Now for our period, let me highlight that one. Period is the number of degrees or radians that it takes to complete one cycle. So actually I probably should have taken this, and that's actually 360 degrees. Okay. Now, the way you find this is also our horizontal stretch or compression. Let's go ahead and write that down. So horizontal stretch, or I'm going to write compression first because I said stretch, but I wrote compression. Okay. Now remember, this is like if we wrote cosine b of theta. Remember, it's on the inside. Remember, back in Unit 1, if you don't remember, you might want to look, but we always multiply by 1 over b. Okay? So that's how we find out what our period is. Okay? Which you'll see written more like that. These two things that I just wrote are the same. Okay? Now, something else we talked about. Well, actually, let's just go ahead and do amplitude first. Okay? So notice our amplitude is on, if we're looking at number 1, we got y equals 4 sine of theta. 4 is our amplitude. which means that we are then going to stretch our graph, the distance from our sinusoidal graph, so the x-axis, by 4. Okay, so remember with our trig function today when we were graphing our spaghetti trig, we start at 0, 0, and we're stretching it up to 4. Notice I've always told y'all that our radius will always be 1 unless I state otherwise. Well, this is a case where I'm stating otherwise. We're changing it to 4. So now our distance up to 90 degrees is 1, back down to 180, then -4, and then 360. So I want y'all to try as best as possible, making it a smooth, like, oops, and I should have intersected, a smooth graph. I don't want to see any straight lines because that's not correct. Now, some of y'all probably are wondering why we only graph 0, 90, 180, 270, and 360. That is because we are only graphing our critical points, okay? With our spaghetti trig, and I did it only because I wanted you to see the graph, we did 0, 30, 45, 60, 90, so on and so forth. But critical points are the points that are the high points, the middle points, and the low points of the graph. Notice, my high point would be at 90 for a sine. Middle points would be when it crosses the x-axis, and then low point would be when it goes the furthest down. So that's what we're graphing. Okay? Now to find your critical points, you're going to take 360, and we're going to divide by 4 times our b value. Okay? We're going to talk more about this in a second, but I just want you to have this written down. 4 times our b value. And notice we didn't change our critical points in number 1 because we did not change our period. Okay? So I should have filled the rest of this out. This is +4, 0, -4, and 0. Okay, so the amplitude of y equals 4, sine of theta is 4. Okay? Moving on. Example 2. Okay? I want y'all to go ahead and figure this out. You can go ahead and press pause, and I'm going to fill this out, and I want y'all to try it by yourself as practice. Note the key thing, it's cosine, not sine, so we're starting higher. So go ahead and press pause, see if you can get it yourself, and check back with me. Okay, if you had this, you are 100% correct. Okay, so the graph of y equals a sine of theta has an amplitude of a. Okay, moving on. Now we are going to start changing our period. So in our case, on number 3, we've got graph y equals sine of 3 theta. So b is 3. Before you do anything, and they actually have that all filled out, basically what we're doing is we're taking 360 and we're dividing by 3. So we know that our cycle is going to repeat itself every 120 degrees. Okay? Now, so that's our cycle is 120. To figure out what our high, middle, and low are our critical points, we're going to take 360 and divide it by 12, and we get 30 degrees. And this is showing you how you get the 30 degrees. Okay, so we got 0, 30, 60, 90, and 120. Okay, we're not changing any of our amplitudes, so it's going to be the standard sine is 0, it starts at 0, 0, goes up to 1, 0, negative. There you go. Okay? So 0, negative, or positive 1, 0, negative 1, 0. So the period, we already wrote it down, is 120, and there's a critical point every 30 units. Okay, that's where we got that from here and there. Okay? Again, press pause, work through example 4, and I'm going to go ahead and fill it out. So I want you to check back with me. So our B is 2, which means we're going to take 2 pi and divide by 2 because we're in theta. And it means we're going to have a critical point every 2 pi divided by 4 times 4 times 2, which means every pi over 4. So we got pi over 4, pi over 2, 3 pi over 4, and pi. So our graph would look like oops, I made an extra one. I was like, what did I do? Okay, so that's my lowest point, and then we go back up right here. So if you had this, and I should have marked my labels, but I know y'all did already, so you're fine. Pi over 4. Okay, so the period of cosine of b theta is 360 divided by I'm looking at 360 divided by b, or if you're talking about radians, it's 2 pi divided by b. And there's a critical point, 360 divided by 4b, which is the same thing as 2 pi divided by 4b. Okay? Now, we have a couple examples for here, so I'm going to walk you through one. And if you feel like you need more practice, go ahead and work through it. And come see me in the morning if you have questions about it. All right, so example 1. A, our amplitude is 6, so that means we're going to go up to 6 and down 6. That's it, as opposed to 1 or negative 1. B, our B value is 5. So we got 360 divided by 5, which means our cycle is going to happen every 72 degrees. Okay? And they want us to do 2 cycles of it. Okay? So we're going to do 120 or 72 degrees and then one at 144. Okay, and then to figure out when our critical points are, 360 divided by 4 times 5, we got 18. So we got 18, 36, 54, so on and so forth. Go ahead and fill those out. Press pause if I'm going too fast. Okay, and I'm going to use a different color as well. Okay, so we have cosine, which we know starts up at the axis, then goes to the middle point, low point, high point. And, oh, whoa, hopefully your graph isn't as messy as mine, but it should go through like that. So I apologize, okay? And if you mark it this clearly, you don't need to do you don't need to sit there and write 118, 0. You don't need to do that unless you want to. But if yours is marked nice and neat like that, I will take that. Totally fine, okay? If you think you got a hang of this, you can go ahead and end it. But I would like for you to sign off, and I will see y'all tomorrow. Thanks.